Hello, I'm Dan Prinsinski, the President of Applied Energy. I'd like to introduce Bill Hinton, the Director of Engineering. Bill is going to step us through the demonstration of the Applied Energy product line. Bill, I'll turn it over to you.
Thank you, Dan. The first product we're going to be demoing this morning is Phaseback. What we have at this point is simply the power coming from the building, feeding an across-the-line starter, running this motor. I have a control to turn this motor on. We're showing the three-phase voltages here, and we're showing voltages to ground of 315, 291, and 248. Dan, if you'll turn that on.
Well, Bill, in a facility, what, if any, operational problems would that imbalance cause?
If you have more than a 10% imbalance, that'll cause adjustable frequency drives of various brands, types, and models not to function. It can cause other issues, but the biggest issue is with unbalanced voltage feeding motors, motors can run hotter. So shortened motor life is one operational effect of having an unbalanced voltage. Turn this on. Now we have 279, 281, and 281, or actually 280, 281, and 281. So we're extremely close to being exactly the same voltage. So in addition to balancing the phase voltages, we do not require anything else to protect the system. In many distribution systems where you have sensitive equipment, you have a problem with electrical pollution or noise from all over the place. Mother Nature makes noise every time there's a storm. Your neighbors make noise, comes in on the power distribution system. All of your adjustable frequency drives, switch mode power supplies, which is power supplies in every computer, every CNC control, and many other pieces of equipment. As loads are turned on and off, you'll have spikes in voltage and surges in current that will affect this. One other aspect is harmonic distortion. I'm going to switch from our live scope mode to harmonics. And could you turn that off again, please? We'll look at the harmonics. Okay, our total harmonic distortion, many people are targeting to get below 5% of total harmonic distortion. We have 7%, that is the harmonics in this building. This is not simply from our demo here, it's from actually everything in the building contributing to harmonic distortion. And everyone tries to shoot to be below 5%, but they don't know how to get there. Let's turn us Phaseback on. Okay, now we are at 1.7%. So we have reduced the harmonic distortion by well over 85%.
And Bill, based on the problems that you discussed that the harmonics can cause, what we are looking at here is the first two benefits of Phaseback is we stabilize the voltage, we've reduced the harmonic distortion, so the problems that are associated with that are no longer an issue in any facility that's operating.
Right, absolutely. With Phaseback, it does not make any difference where the noise comes from. One Phaseback anywhere in a power distribution system not only helps but eliminates the noise from all sources at the same time at any frequency. We actually are displaying an entire harmonic spectrum, and they're all well below 0.5% individually, totaling just a little bit above 1.5%. Harmonics, we had a significant amount of third harmonic originally. The third harmonic tries to take electric motors and make them stand still. It's a zero sequence, or tries to stop the motor. Well, it obviously can't stop the motor, so it just makes the motor generate additional heat. Now, I'm going to go back to this live scope mode where we have our voltages balanced to talk briefly about transient voltage suppression. Most technologies of transient voltage suppression allows voltage to get very, very high before it engages to try to invoke a correction. When it tries to invoke a correction, it takes that high voltage spike, converts it to a high current surge. Manufacturers have various ratings like 20,000 amps or 50,000 amps. We don't believe it's a good idea to put a very high current on your ground system. We're going to actually show injecting 200,000 volts directly to one lead of our running three-phase motor from our 200,000 volt Van de Graaff generator. Now as we look here, we're seeing live scope mode of the actual voltages on this motor. We're connected right to the phases, right to the wires going to this electric motor, and we don't see any noise whatsoever. In fact, injecting 200,000 volts, the maximum voltage change we've seen is 0.2 of a volt. Typical transient voltage surge suppressors have to be tested to withstand some relatively high voltage, possibly 6,000 volts for a few microseconds of time. We've run this demo well over 20 hours at 200,000 volts, which we're quite sure would destroy any other suppressor.
So Bill, then what we're actually looking at here is we've got one product with three distinct benefits.
Exactly. Surge suppressor companies tell you you need a surge suppressor for every sensitive load, and you need to put them as close to the source of the noise as possible.
That's to minimize clamping voltage, right?
Yeah, and how do you know where the source of the noise is going to come from? With Phaseback, it doesn't make any difference where it comes from. A facility that has one power transformer needs one Phaseback, and every piece of equipment in that facility is protected. Another benefit of Phaseback, we have been doing some research on high voltage spikes coming into a facility from any source, from lightning, from some enemy potentially shooting off a electromagnetic pulse bomb. And in research, we found that whatever's happening outside the facility, typically less than 50,000 volts will be present on the load side of the power transformer. We're already protected well above 200,000 volts, so we know we can take the voltage. We've already suppressed transient voltage spikes in the gigahertz frequency range, which I believe the EMP pulse runs from tens of thousands of cycles per second or hertz to many gigahertz. So we're already well on our way to protecting a facility. We're very confident that a facility with Phaseback would not have its equipment fried inside, no matter what's happening outside.
To summarize what you've seen here in this demonstration, every one of these products affects the bottom line of your operation. If you want maximum productivity, maximum profitability, contact us.